This is a Raypak HiDelta. It helps you start diagnosing it before you even pull out your tools with these 4 lights found in the front center panel. Each light indicates something different. So the green light indicates that we have proper high and low voltage. Orange is a call for heat or indication that the thermostat is signaling for the boiler to come on. The blue light means that the burners are on or the boiler is actively heating up. Red means the unit will not try to turn back on by itself. One of 2 things have tripped. The first one being this high limit switch. This is a safety device that completely shuts off the boiler if it goes past a certain set point. And these are usually set to about 200 degrees Fahrenheit for domestic hot water. In order to reset this switch, the red button in the middle of the control needs to be pressed. The unit may attempt to turn back on once the red button is pushed, but that does not mean that's the solution. There could be some other underlying issue to why it's overheating. The second reason for that red light to be on can be caused by the low gas cutoff. This safety device turns off the boiler if it loses gas pressure. It can be reset by pressing the black button on the top corner. Once reset, make sure you have the proper gas pressure. Also, you might need to bleed the lines of any air or else the unit will not turn on. Those are reasons why the boiler would turn off. So here's a sequence of the boiler turning on. First, we get a signal from the thermostat calling for heat. The thermostat or aquastat regulates the temperature inside of the storage tank, and the normal set point is between 135 degrees and 145 degrees. After the thermostat calls for heat, the next step is to ensure we have water flowing through the heat exchanger. This is done via the flow switch. The flow switch is just a paddle with a single direction of water flow that closes the contact. The flow is produced by the pump on the outside of the boiler. The pump is on the inlet side of the boiler to ensure we have proper water flow going through the heat exchanger. The pump is what dictates the direction of the paddle for the flow switch. Step number 3, the blower or blowers come on. These are 120 volt motors and get signal directly from the ignition control board. The blowers turn on and blow air into the combustion chamber. The combustion chamber needs to be pressurized with positive air pressure to ensure that all the exhaust fumes go up through the exhaust vent. The unit ensures all the fumes go out through the vents via this dual pressure switch. Once it senses positive pressure in the combustion chamber, it sends a signal to continue with the ignition sequence. Once that pressure switch closes, we go back inside the center panel to ensure the igniter is coming on, which is step number 4. You can check the igniter by using an amp meter on the orange wire coming out of the fin wall ignition control board. The igniter needs to pull a minimum of 3.1 amps to continue with the ignition sequence. Once the proper amp draw is reached, the gas valves get 24 volts and the burners come on. The final step is for the flame sensor to prove that there's a flame. It does this by the flame hitting that rod directly and producing millivolts, telling the fin wall ignition control board to keep the gas valves on. If the boiler does not stay lit after the blue light comes on with the burners, the issue might be that the flame rod is dirty. It can be pulled out and cleaned using sandpaper. At this point, the boiler should stay on until the thermostat reaches temperature. The only other thing that may be needed is for the filters on the boilers to be cleaned very frequently. So these do get pretty bad, and anything that gets sucked into the boiler will go straight into the burners and probably damage the boiler. And that's the basic operation of a Raypak boiler.